Many also can be modeled using non-relational databases, right? And it's here's an example of faculty and who are authors or teaching the courses or sections. Notice that these are aggregates, right? Where the faculty has a reference to the courses and the sections, but there is no life dependency between the two. If the faculty goes away, presumably I can find another faculty to teach the course, right, or that section, or to author that course, right? So I don't lose the course, I don't lose the section if the reference to the faculty is lost. So here as well, right, in a relational database, there was only one way to implement this. Well, actually, no, there were two, right? If you have a one-to-many between A and B, the classical way of implementing it is that B has a foreign key to A, right? It's the classical way of implementing it. You can also implement it using a mapping table, right? Saying that B is associated to A, right? Because a one-to-many is a subset of a many-to-many. Yes? It's just that it goes one direction as opposed to going in both directions. But here in a non-relational database, there's a third way of implementing it, right? And the third way of implementing is that now I can have a field that has an array of the children, right? In a relational database, you can do that, right? It could only be the children, referencing the parents, never the parent referencing the children. But here, because the arrays are a normal data type, right? You can have faculties pointing to the courses that they authored or sections that they taught, right, as arrays of foreign keys of the courses and the sections that they're teaching or that they're authoring. Right? So it's perfectly fine. But there is an additional way of doing it as well, right? If this is an aggregate, then typically the way you would implement that is by just keeping track of references. Yes? But if this is a composition, right, where the if you remove the parent, the child also is removed, right? We have a composition like that. Then another way to implement it is to embed the child inside of the parent, right? Where you don't have a separate collection. This doesn't exist outside of the parent, so that if the parent goes, the children go as well, right? Now it depends whether it makes sense to you or not, right? It depends on the use cases, depends on the modeling, the way that it's described in the problem statement, right? If it's either one or the other, but certainly in a relational database, you can implement it using cascade delete, right? Where you can say if that is removed, then it cascades down to the child. Here, in a non-relational database, it can be implemented as an embedded object, where the object, I don't have a reference to the object only exists inside of the parent, right? It's embedded inside of the parent, so that if I remove the parent, everything under there is gone. Okay. Now, for performance purposes, from Mongo's point of view, this is the preferred way of implementing the data model. Right? If you, as much as possible, if you can, you would implement it using embedded objects. Only when you risk redundancy and risk inconsistency, then you would not do you would do embedded objects. Okay, but if you can get away with it, this is the preferred. Right? Ideally, when you do a query from the database, right, you want to get as much data as possible out of the database into cached memory, right, as opposed to doing. You want to minimize the I/O, right, that goes back between the application and the database, right? Every single I/O is very, very time-consuming. So once you've done the I/O, you want to bring as much data back to the database and then cache it in memory. Or even if this is a remote query, through HTTP query, you want to minimize those even further, right? You want to make sure that you do large queries, you get lots of data out, right, as opposed to making many tiny little queries. You want to minimize the chatter, the network chatter between the parent and between the server and the client. So yeah, so here's the typical way of doing it, the normalized way, where you have the sections pointing to the parent, or the embedded objects, and we'll talk about that next Thursday.